All right, so I'm Charles Dasher. I'm a technology design lead for Ericsson. I work out of Atlanta, Georgia, in a little part of the company that we call the Atlanta Idea Factory. So what we've done is we've created a thing that we call connected water. For Ericsson, sustainability is so important. We have entire initiatives, for example, our Technology for Good initiative, or the work we do with the UN, or our work with refugees, or dropping cellular networks in when we have earthquakes in places like Nepal. So it's really important for us. At our core, we really have this sense of being green. And of course, we also have a vision for 2020, which is the network society. We believe that everything is going to be connected, and we are the ICT connectivity partner that we hope everyone's going to work with. So when you're talking about environmental monitoring and environmental sustainability, there are really only one category of device on the market at the moment, and those are industrialized devices that are made for municipal water systems or for governmental agencies, and so they're very expensive. In Atlanta, Georgia, there is a river called the Chattahoochee River. It runs from the mountains of the north all the way down to the Gulf of Mexico through Alabama and Florida. And this is the source drinking water for 4 million Atlantans, so it's a pretty important body of water. It's monitored by an organization called the Chattahoochee Riverkeeper, which is an environmental advocacy organization. They've been around for 25 years. 25 years ago, the Chattahoochee was one of the most polluted rivers in the country. Now it's one of the cleanest because of the work of these people. Unfortunately though, the tools they have are those industrial tools, so they're really expensive. For example, to test water, they actually get on a boat with one of these $10,000 devices and they go up the river 3 days a week, checking 70 sites. Put it in the water, take it out. Put it in the water, take it out. Or they rely on the community to bag water samples and bring them to their office. So they approached Ericsson to say, what can you do to make this better? So the first thing we did was, we said, what do the sensors do? And they do a number of quality of water measurements. Conductivity, which is how much stuff's in the water, like how many salts and things like that. Turbidity, which is how clear the water is. Think a bottle of water versus hot cocoa. Temperature we use in calculations, as well as fluorometry, which is the detection of the fluorescence of a substance like laundry detergent, which is a great indicator of E. coli, because when you have a sewer spill, there's almost always toilet paper and laundry detergent. So what we've done is we've taken a $10,000 device and we've shrunk the cost down to almost under $300, including connectivity, and we've connected it using LTE Category 1 power saving mode, which is a very new thing. It's part of the standard, but Ericsson's one of the first companies to deploy this. And this allows us to have an increased amount of sampling in terms of how often during the day do we take samples, but more importantly, it increases our battery life by years and years and years. So it's a really great thing for us. Currently in Atlanta, we actually have some of our sensors deployed in Proctor Creek, which is an urban creek in Atlanta, and urban creeks are vitally important as part of the ecology. These creeks can sometimes have school children playing in them, other times they're filled with tires and debris. So our sensor is in there, making sure it's clean, and that's actually done with your cooperation with AT&T, who is our connectivity partner in Atlanta. So if you like, I can show you this demo here, which is actually, so currently right now in our tank, we have clean water. And we're going to introduce a sewage spill. Now, sewage spill, we're actually going to put dirty water in there. And by dirty water that actually has laundry detergent in it. It actually smells nice, it's pretty clean water, but for a river, it's dirty. Our fluorometer is going to actually fluoresce the optical brightness that are in the water, and we're going to read it, and we'll be able to detect that there is a sewer spill. And so we can alert the community, we can then do big data analysis, we can start building what we call a river signature, which is really a trending data over one or many sensors, so we can really kind of get a hold of, what's the river really like, when is something bad, when is it not bad? And that's what we're doing with connected water.